Hello, YouTube. It's the Atheist Guard here. I'm Gregory Garrett. I'm going to be doing a brief talk about alternative hypotheses regarding what came before the Big Bang. Now, I'm just a layman, I'm not a cosmologist, but I've read a lot of stuff. Now, what I would be most comfortable with saying, which I think most cosmologists would actually say, is that we don't know what happened before the Big Bang. But this is often a convenient gap for theists to insert a God, because it's one of those big unknowns, and seeing how it sort of sounds like creation, it kind of fulfills a necessary hole that their God would fit into. Because of course, a God being a magical entity can do anything. So if you have an unanswered question, that can be your answer, is that magic did it. I mean, God did it. Same answer. So I would say I don't know. But being a human and falling prey to inductive reasoning, it helps to have alternative explanations for what came before the Big Bang. It just helps the brain kind of deal with that hole in our knowledge. Now, we would still say we don't know, but here are some good ideas. Some alternate ideas that don't involve magic, that don't involve an intentional act by an invisible entity, which we have no reason to expect exists. We have no evidence for it. It's just a convenient answer. It's a panacea answer that kind of fits any hole that you don't have an explanation. So I'm going to run through this real quick here and make use of a blackboard for once so you can see what I'm talking about. All right. This is the expanding universe. This is the singularity. We're going to call that T equals 0. Time equals 0. There was no time at this point. Time and space came from the Big Bang. It's not like an explosion in space. It is space. Space expanding. That's what the Big Bang is. Now, this is the present day. And what we can observe in the present day is that it's getting bigger. We can observe this. The distant galaxies are receding from us and from everything else. The universe is expanding. We know this. So the idea is, well, we know it's expanding into the future. That's going to keep on getting bigger and bigger. Then if we rewind that and think of it in terms of the past, it gets smaller and smaller and smaller until at some point it reaches a singularity. T equals 0. Now, the big question is, what happened here? Nobody knows. We can't know. As a matter of fact, we don't know what happened here at the actual point, let alone what came before that, if before even made sense when T equals 0. What we do know is a good idea of what the universe was doing 1 Planck second after the Big Bang. We don't even know what happened in this area. When the universe already existed, was already expanding, that first Planck second of expansion, we don't know what's going on there. Mainly because our mathematical models, even causality itself breaks down inside that first Planck second. I mean, quantum mechanics is a pain that way. There's only so much you can say, and it always goes down to the Planck scale. Whether it's Planck time, Planck size, there's a minimum amount you can divide something in this universe. It's quantifiable. Everything's quantized at the Planck scale. And below that, there's so much uncertainty as to what can be going on that we can't say anything about what can be going on. And that's the thing that quantum physics taught us, is that there isn't an absolute state for anything. Everything is just a compiled convergent set of probabilities. Now, back to the question at hand. People tend to disregard anything having to do with infinity as if it's just impossible, because they don't like infinity. Infinity is like, how do you wrap your mind around that? Well, that's also completely irrelevant. Whether or not humans can adequately conceive infinity or an infinite sequence of events doesn't mean that it's impossible. Just because you don't like to think about an infinite sequence of events doesn't mean it can't be the case that there's an infinite sequence of events. And what's kind of amusing is that in place of an infinite regress, the theists will propose a God who has eternally existed, has always existed, meaning his existence is infinite in both directions, not just into the past. They're okay with that infinity, but they're not okay with an infinite regress of natural events. That's special pleading. Sorry, it is. Now, I have no problem with infinity myself. I can't fully wrap my head around it, but I get the idea that this singularity state could have always just been until one point it started to expand into our universe. I don't see any problem with that. And why did it go from being this compacted state to suddenly expanding into our universe? I don't know. Again, you've got a big old question mark. Don't know that either. This is all just hypothetical. That we actually don't have a way of testing. It's conjecture. It's worse than hypothesis. We have no way of knowing what's going on in this whole sequence before that first plane second. All this is conjecture. But we can make conjecture without having to invoke magic as a causal agent. We can still think of things in terms of natural sequences. We don't have to appeal to a higher being or magic to make sense of any of this. Now, why we went from being a singularity state to suddenly expanding into the universe could have been something analogous to a quantum event. Quantum events are uncaused. The whole first cause argument requires that every cause has to be caused by something else. If there's a chain of causes going back, no. We now know that's not the case. There are uncaused events in the universe. There are uncaused processes in the universe. They're just random. They just happen. They don't have to have a cause. So something analogous to a quantum effect could have caused that singularity state to suddenly expand into our present universe with all the galaxies and stars and all that stuff. Now, another idea is that before the Big Bang, again, supposing that that makes sense when t equals 0, if we can think of a timeline independence of our universe that extends into infinity to the past and the future, then before that there may have been a collapse from a previous universe. That a universe will expand and expand and expand, and it eventually slow down its expansion and eventually start collapsing on itself. Now, we don't have any indication that this is happening in our universe. This is our universe. It seems like it's expanding at an accelerated rate, as a matter of fact, that it can't slow down. That if anything, it's just going to keep on expanding until it basically falls apart. But we don't know what happened to the universe, the potential universe that came before our universe. It could have had an insufficient expansion rate such that gravity eventually caused it to contract on itself, getting smaller and smaller and more compact and hotter because everything's getting squeezed until it reached this singularity state, which would have been inherently unstable. It couldn't stay at a singularity, so it had to re-expand into another universe. And there's nothing that says that the laws in this universe have to be the same as the laws in this universe. There's nothing that says that this universe that came before couldn't have contracted to form our universe, which won't contract in the future. Now, we're pretty certain that this is not going to happen. That instead, it's just going to keep on expanding at an accelerated rate until everything is just diffused and the atoms and everything just fall apart. And we're talking trillions of years from now. So this reproducing universe sequence would look something like this, where a universe begins, expands, contracts, and then begins another universe, which expands and contracts, and begins another universe, which expands and contracts, and so on and so forth, into infinity in both directions. Or, as it's expanding and contracting, things change in each universe. Something goes awry in each universe, something randomly fluctuates in each universe, such that some amount of energy is bled off of those universes, such that the expansion rates constantly shift. So you get to a point where you get this unstable expansion to where one universe finally expands until it just falls apart altogether, ending that sequence. But it could still be infinite into the past. It would just fall apart at some point because it's lost enough of this energy. And we're talking about a higher dimensional type of energy here. Again, completely hypothetical, completely conjecture. The real answer is we don't know what happened before this. But all of this, none of this requires a sentient being, a God, to explain why this is. Now, of course, thieves might ask, where did this come from? Why does it have to come from somewhere? We're talking about universe sequences here. We're not talking about something that has an evident origin or beginning. I mean, that's the whole point of this. That it could be infinite, that it could have always existed in this state. I'm sorry that kind of like rubs you the wrong way because you like to think that everything had to start from something, but we now know that is not the case. Even inside our universe, that's not the case. That there are random fluctuations, that things actually pop into existence out of nothing and then annihilate each other. These are virtual particles. We know they're real. They're just called virtual to differentiate them from the particles that actually do things in our universe. And we know these are real because there's a prediction made in another model that these will cause Hawking radiation near black holes. Of course, now, I'll go ahead and explain that real quick. So here's black hole's event horizon. That is, black hole at the center. Anything traveling outside the event horizon will have its path altered, but can escape the black hole. But if you enter that event horizon, you're screwed. You're going to encounter that black hole once you pass through that event horizon. That's there's no way to get out of it. Even light coming from the black hole will just loop around and go right back to it inside that event horizon. I mean, it's got to be apparently black to an observer here, but it'll be like blazingly radiative white to any observer inside that event horizon, because all the light coming from that collapsed star, all that energy is being cycled back into that star. So when you have a virtual particle pair that appears near the edge of a black hole, one particle will be outside the event horizon, one particle will be inside the event horizon. And what's going to happen is, well, this one gets sucked into the black hole and ceases to exist in any recognizable state, and this one gets to wander on free. And if you've got enough of these going on, which happens a lot, you get this emission from a black hole. Well, it's actually an emission from the boundary of the event horizon, but basically the black hole is going to emit this type of radiation as this free pair of that virtual particle pair escapes. And this is called Hawking radiation, and it has been confirmed to exist. Another experiment demonstrated the Casimir effect, which is also due to virtual particle pairs expanding away from each other and then collapsing, causing a pressure. I may not be explaining that one quite correctly because I'm not that versed on that particular experiment. But regardless, we know that there are things in this universe that are uncaused, and thus there could be things outside of this universe that are uncaused. I mean, it might be a composition error, a type of fallacy in that regard, that what we expect to happen in our universe should be expected to happen outside of our universe, but also we don't know that it can't. It's all conjecture. We're just kind of making things up as we go here. You know, just like theists do. They just insert magical man did it at this point, instead of coming up with things that don't require magic. Now, so we got this infinite timeline, independent of our timeline. It happens to be parallel to our timeline. This is our timeline right here, which will expand infinitely into the future. But it expands infinitely into the past, even though our timeline does not extend infinitely into the past. It seems to have originated at the Big Bang. Time seems to be inherently tied to space. Of course, in this case, we're representing space as a one-dimensional feature and a one-dimensional time, and what we really have is apparently 3 dimensions of space plus 1 of time. But it doesn't actually stop there. It was more like we have 5 dimensions of space and 1 of time. And of course, time itself breaks down into several different types of time, including the psychological time that we experience as humans, which is entirely subjective, that we only remember the past and not the future. There's also the thermodynamic arrow of time, which is basically this one here, that as the universe expands, time flows in that direction. That's the thermodynamic arrow. And there's other ones as well. Cosmological arrow, which happens to be parallel right now to the thermodynamic arrow, but if the universe were to collapse, they would be pointing in the opposite direction. You have cosmological time, thermodynamic time, they'd actually be opposites. They're independent of each other. One has to do with the expansion, one has to do with the actual direction, the actual fate of the universe, so to speak. And of course, this isn't exactly accurate either, because the mathematics that unite everything, all the forces, all the particles, seem to suggest that we have a crap ton of dimensions, that it's like 26 dimensions. Or at a minimum like 10. I mean, you can kind of boil it down to 10 if you generalize it in certain ways. I don't even pretend I can do the math on that, or even that I wrap my head around it entirely. But regardless, what we're dealing with here is, this is what we know. And we can kind of say, well, 13.73 billion years ago, this would have been the condition. We don't know that this was the condition. For all we know, that never happened. Because all we know is what the universe was doing 1 Planck second and onward. So there may not have even been a singularity. Singularity is just a mathematical construct. It's the inevitable thing if you rewind it all the way back. But we don't have a reason to think that that was ever actually a state. The Big Bang just describes an expansion. It doesn't describe the actual singularity, because the singularity is just a conclusion. It's not a demonstrable thing. So for all we know, that could have been more like reality. That there was always some extent to the dimension of space, 1 Planck length, and that time itself has always been infinite because it was never reduced. So, of course, nothing could really form in this particular state, and this is basically analogous to taking that singularity point and stretching it. Well, not stretching it into the future, but stretching it into the past, into an infinite past. So, that could be a possibility. Because this is all we know. And of course, we confirm these things because the Big Bang Theory makes predictions. It's a really good theory in that regard. Is that it says, if you look back at this particular point in time, at this particular distance, because distance and time are related, so many billions of light years away, you should see this. And we've looked and found it. We'll launch satellites like the COBE or the WMAP, and we can observe these things and confirm that they match the predictions precisely. Like, if this was the graph of the data, and this was the prediction that the theory made, the data came in like this, for our data points obtained by direct observation. Now that's pretty compelling evidence that the Big Bang Theory is not only a good idea, but actually reflects reality. Because we've observed that the predictions it makes, that it necessarily leads to, match up with observation. Direct observation. See, then that's the cool thing, is that you can actually look back in time. Anytime you look at anything, you're looking back in time. But if you're looking at things on the astronomical time scale, you're looking way back in time. I mean, even the nearest star from us takes 4 light years for, that's the distance it has to travel, the light has to travel to reach us. So you're looking at the star as it was 4 years ago. Now, if you look at something like a distant galaxy, you're looking at it how it was millions of years ago, or billions of years ago. Depends on how deep you look. So you build these really massive telescopes, and you look back into time and see what the universe was doing at these various points in time, and they also match up with the predictions of the Big Bang model. So we know this part is pretty solid. Now, the other alternative hypothesis is that there is a multiverse, that you've got universes coming into existence with various properties. Some happen very quickly and then recollapse on themselves. Some of them expand forever. Some of them do this nice, Big Bang, Big Crunch sequence with their time axis. Some of them have totally different spatial dimensions, totally different laws of physics, and this is ours. And life is compatible in ours. I mean, it's not compatible here, as we know it. Some other type of life could live there that works on completely different principles, completely different laws of physics. But the life that we recognize works in this particular universe, because that's the one we're in. It's the anthropic principle, only in reverse. It's like, why does the universe look like it's fine-tuned for life? Because we're in it. We're the ones that we're in that universe. If it wasn't fine-tuned for life, we wouldn't be in this universe. We would be in the other universe that is fine-tuned for life. It's not really tuned by anything. It's just, if you got enough universes, you don't even have to have an infinite amount. But I'm comfortable with infinity, so I'm going to say we have an infinite number of universes. One of them is going to be just right for us. And ours isn't even that good for us. Ours is almost entirely hostile to life. Life is almost impossible in our universe. It's barely compatible with our type of life. Hell, we might actually discover a life form in our universe that's way more compatible with this universe. Maybe it can survive in the vacuum of space. Maybe it doesn't have such a heat tolerance restriction as humans do. Maybe it can survive in a wide range of heat. Maybe it doesn't need water. There could be a vastly better life form inside our universe than we are, because we can barely survive on our planet. And if you look at our planet, you can't survive in this portion of our planet because it's salt water. It'll kill you from exposure. You can't drink it, and you can't breathe underwater, and you will eventually sink. You can sit there and tread water all you want, but at some point, this is the area of our planet where we can live, the land, about 23%. And of that, this amount is glacial. You can't live there because it's too cold. I mean, without technology, you really can't go there. Even with technology, it's prohibitive because it's really quite possible that you're going to have a problem and die anyways. Your heater's got to break down, your vehicle's got to break down, whatever shelter you're relying on has got to have a problem. This portion right here is desert. Humans don't do well in deserts either. Again, without our technology. The only reason we survive so long in this inhospitable universe is because we're smart. That's our one survival. That's the one thing natural selection managed to get us, is a pretty good sized brain so that we can survive on our overly hostile planet. We're not fast. We're not particularly strong, especially compared to some of the other predators on this planet. But we got the big brain. And these nice fingers that we can use to manipulate things so that we can make things that can actually help us survive. That's our survival advantage. Otherwise, we'd be screwed in this universe. This universe is almost entirely hostile. Our planet's almost entirely hostile to our existence. Unless we come up with clothes and insulation and air conditioning and all these other nice things that make it possible to live in Tucson, Arizona, or Antarctica, But yeah, the multiverse, we have to be in the one that works, because if we were in the one that didn't work, we wouldn't be here talking about it. That's another explanation. Again, no magic required. You don't even have to accept the idea of infinity in that case. There could be a large number of universes, but not an infinite number of universes. Just enough of a large number that this one would eventually happen. One like ours, where it's marginally compatible with life. But, there could be a way better universe out there for humans where maybe, let's say, instead of a void, space was permeated with an atmosphere. There's an atmosphere everywhere in that universe. You could breathe even outside of a spacecraft, even if there's the same thing as gravity and all this. That would be a universe that we would survive a lot better in. Maybe there's a universe where, I don't know, atoms don't fall apart eventually. But this isn't going to happen. Or maybe in the very beginning, the actual laws that describe those atoms are completely different, such that the atoms wouldn't fall apart, even given enough time, that they're just a totally different type of atom. They'd be more stable. Maybe there's a type of life form in one of these universes where their genetic code wasn't so easily malleable that they fall apart, basically, and have to suffer from genetic illnesses, cancers, and things that rewrite your code, viruses. I don't know. I mean, you can think of a few conditions that you could change that would make this universe vastly more compatible with our existence. But we ended up in this one. It's just barely compatible with our existence. And yeah, if you change a few of those parameters, our universe is not compatible with our existence. But that doesn't matter. It's not like that's an indicator of fine-tuning, because there could be other universes where we don't exist, and we are in the one that is compatible, barely compatible with our existence. Or there could have been an infinite sequence of universes leading up to our universe in which, nope, not good enough for our existence. Nope, there's something wrong with that one too, can't exist there. Oh, that one happened really, really, really quickly, so life didn't even have a chance to develop in that universe. Oh, good, finally, we got all the parameters just barely good enough for us to exist. Oh, I guess we're in this one. I don't see the problem. I don't see the big mystery there. That we are in the universe that's compatible for us. That we reside on the planet in our universe that is just barely compatible with us. I mean, think about how many planets there are in our universe, how many stars, galaxies, planets. At some point, you're going to have a planet in just the right place to where it's barely compatible with our type of life. And that's discounting the idea that there could be other types of life that could exist on planets completely different from ours under completely different conditions. Like, if there's life on Jupiter or something, it would be different from us, but it would be perfect for that life form on Jupiter. So it all boils down to this egotistical notion that this universe had to have been made for us because we fit in it. I don't have that much of an ego. Sorry, I don't see it. I see a universe that barely works with our existence and has plenty of alternative ideas that could explain why it's here in the first place. The final idea, which is probably my least favorite, is that as t approaches 0, it also approaches infinity. Yeah, I know, I don't like that either. But the idea is that it's an asymptote. This will be space, this will be time. As the universe gets bigger, it's getting more and more into the future. That's what we see. That's the observation. But as you rewind it back, it gets closer and closer and closer to 0, but never quite reaches 0. That kind of goes back to my analogy where instead of there being an actual singularity, which is just a mathematical conclusion, that it's just this. And everything is at the Planck length, including the Planck time, for infinity. It's kind of that same concept. Well, the point is, this is the best answer. I don't know. And that's the one that gives people the most problems. They don't have the ability to honestly say that. And instead they want to insert something into that nice gap in our knowledge, which extends into infinity, which they don't like, but they're willing to put an explanation in there that itself is infinite in its existence. So that's the big problem I have with the cosmological arguments that theists make. They just don't accept this as the honest answer. This is the honest answer. And when we finally figure out a way to observe, detect, test before the Big Bang, if they can even be done, that's when this goes away. And that's when we have an explanation.